I built a lightweight clone of OpenClaw using n8n. It has persistent memory, it can execute tasks autonomously, and you can talk to it from multiple channels. It's also infinitely expandable by attaching as many n8n workflows and sub-agents as you need. Let me show you how this works. Hey, whatever happened about that YouTube script that I asked you to make? You'll see that the audio is getting transcribed and it's going into n8n Claw. And it actually remembers that I was asking about a Google Doc URL in an earlier conversation. So I want to do option C. Let's go ahead and continue this in WhatsApp. So it started the trigger. It's now going to the document manager and it's going to try to find any files that it created. And because I messaged it on WhatsApp, the reply is going to come back on WhatsApp. And it actually went ahead and it found the video scripts that I was looking for. I've also given it its own email address. It also runs autonomously through the schedule trigger. So when it executes through the schedule, it automatically checks for tasks and subtasks, sees what's pending, and comes back to me with a reply on the last platform that I messaged it on. So you'll see that the conversation is continuing across all of these channels and autonomously when needed. Let me show you how this works. Now for some context, OpenClaw is going viral. People are buying Mac Minis and even Mac Studios just to run it. It's a full autonomous AI assistant platform. And if you go through the repo on GitHub, it's 71 directories, 160 dependencies, and it's just a huge piece of software. Its core functions is working across multiple channels, persistent memory, proactivity, and being able to control your computer through the shell. And I've been using OpenClaw, and I'm really impressed with it, but I was burning through API credits like anything, and I didn't really want the shell access part. So I figured, how much of this can we reasonably replicate with just n8n, which I've already been using for the past year? The three main functions of OpenClaw that make it, well, OpenClaw is persistent memory, being able to communicate with it across multiple channels, and autonomy. Let me show you how I've solved each of those issues and adapted them into n8n. And we'll start with multiple channels. For this workflow, I've only set up 2 channels, but hypothetically, you could multiply this to as many channels as you want, and it's just as simple as copy and pasting and just changing a little bit of code. Here, I've got Telegram as the base channel. So everything starts with the Telegram trigger. Next up, we have a filter where we're filtering out any other request to the Telegram bot and only my number. And that goes into a switch node, which is going to process whether it's an audio message, an image file, or a document. And I'm using Google Gemini for the transcription and analysis, simply because Gemini has a native node for PDF analysis. OpenAI does not currently have that in n8n. Now, all of these nodes go back into a get rows node, which is connected to a data table in n8n. And this get rows node is going to pull in the personality of n8n Claw. So if you're familiar with OpenClaw, when you first initialize it, it creates a bunch of files. It creates a user file, a soul file, and a heartbeat file. So the workaround for n8n is a data table where we have a username, which is a unique identifier for the account. We have a soul, we have a user, and we also have a heartbeat. So it pulls in all of this data. And we've also got always output data on, because in the first run, there's not going to be any data. So it's going to be an empty output. And you'll see why I've done this in just a couple of minutes. So once we pull in all that data, everything goes into an edit fields node where we have a user message, which is this long expression, which basically normalizes and checks for any one of the 4 nodes, an audio message, an image, a PDF, or plain text. And depending on whichever one is executed, it's going to show that result over here. So that becomes the user message. Then we have the system prompt, which is all of the data fields that we pulled from the data table. I'm going to show you one example. So either it's going to pull in the username, and the 2 pipes here are the logical OR operator, meaning if this evaluates to nothing, then we're sending these instructions instead, which is basically an instruction to the AI agent to get this information from the user, which is the initialization of the robot. So we have all of this. So we're pulling in the username, we're pulling in the SOL, and we're also pulling in information about the user themselves. And we're sending all of that as the system prompt. Finally, we're also going to assign the last channel used. We're also going to save the last channel variable, which in this case is Telegram because this stream is coming from Telegram. For any other stream, you would just save it as whatever channel that is. And that edit fields node then goes into the main n8n claw agent. Now the n8n claw agent receives the user message that we normalized from the edit fields node as the main prompt. There's also a hard-coded system prompt as well as the variable to inject all the details that we got from that n8n database. So that covers Telegram. Now the next one is WhatsApp, which I've set up using the Evolution API. I've got a tutorial on how to do that. I'll leave a link to that in the description. So once the WhatsApp message comes in, it's the same mechanism where we're filtering for whatever number that we want to attend to. You could do this for groups as well, where you can filter in only messages from a certain group. We're going to get those same rows and we're going to use another edit fields node in the exact same way where we have the user message, the system prompt details, and the last channel, which in this case is going to be WhatsApp. So on this side, the last channel was Telegram. On this side, the last channel was WhatsApp. So when n8n claw responds, that response first goes through a switch node where we're going to see if that last channel is equal to Telegram. So it's going to go down one route and it's going to shoot a message back through Telegram. And we also have another route for WhatsApp. And if you had multiple channels, let's say you wanted to add Slack as well, so you could just add a routing rule, set up the same expression for that other channel and just give it a name. Now, in case you were wondering why this expression is so complicated, it's because there are multiple edit fields nodes. So if we just try to evaluate each one directly, if any one of those wasn't executed, which it's not going to be because the data only comes down one stream, n8n will throw an error because you're trying to look for something that didn't happen. So the solution is to use .isExecuted to check whether that node was executed, and if it was, assign this value. And that same pattern repeats all the way down. So for the output, it checks where the input came from, and then if it's WhatsApp, it's going to send a response through the Evolution API and WhatsApp, and if it's Telegram, it's going to send a response through Telegram. Now at this point, you might be wondering how n8n claw remembers the chat history, because usually when we set up a memory node in n8n, that memory node is keyed to the session ID or the number. Now, because we're using multiple channels, we'll have to figure out some other key that's going to persist no matter where the input originally comes from. So while we could use that simple memory, because we're building something robust, we're actually going to set up a Postgres chat memory node. So instead of using the session ID as the key, we're going to hard code the key as the username. And the context window length is going to be 15 because there are quite a few messages and quite a few tool calls that the agent has to remember. In case you run into some errors with this, you could try increasing the context length to 20 or even 25 because you're going to be using an advanced model in the main agent, and it should be able to handle a fairly large context window. So that's the multiple channel setup. And if you wanted to add any other channels, for example, Gmail is a trigger where I've given n8n claw its own inbox. So I could send n8n claw an email and it would go ahead and respond to it as if it was a real person. Everything is the exact same. We're pulling the personality. We're passing the email as a prompt in the edit fields node with the additional caveat that we have to tell the agent that this is an email and not necessarily direct instructions from me. And that's just a security measure so that n8n claw doesn't end up responding to random emails with sensitive information. So that's part one, maintaining state across multiple channels. And as you saw in the demonstration, we can very easily switch between WhatsApp and Telegram and any other channel, and the agent will know exactly where to pick up the conversation from. Challenge number 2 is persistent memory. We're already using a Postgres chat memory node, which is saving all of the chats to a database. And that chat history is being passed back into the AI agent. So it does have a certain degree of persistence. However, OpenClaw basically remembers almost everything that was said. So the solution to that is we're going to connect a vector store to n8n claw. So I have a schedule trigger running, which finds that user ID that I've hard coded. Again, you'll have to hard code certain things to make this work. It finds the user ID and then it executes a query to that same Postgres database where we're saving all of the chat history. It's going to combine all of that, send it to an LLM, which is going to summarize that entire day's discussion, because this trigger runs once every 24 hours. It's going to summarize all of that information, and then it's going to upload all of that to the Supabase vector store, which this agent has access to. And the system prompt contains instructions for where, if the agent requires more context on what's being said or what needs to be done, it can pull the vector store, pull any information from previous chats and conversations, and use that as context to do whatever it has to do. And in case you're wondering how n8n would understand which messages have already been sent to the vector store and which are yet to be sent, that's done by saving the index of the last message that was uploaded to this initial data table in a field called last vector ID. And in this SQL query, we are actually going to filter by that last vector ID. It's only going to check for data points that are after a certain point in time. And once this whole workflow is completed, it's going to grab the last vector ID from that Supabase query and save it to the database. So when this cycle repeats the next day, it's only going to query everything after that message. So far for persistent memory, we're using Postgres and a vector store, but this agent actually takes things one step further. And this is something that is actually not built into OpenClaw, and a lot of the tutorials about how to use OpenClaw actually encourage you to do this step at the very start. And that is to create a running database of everything that you're expecting n8n Claw to do. So aside from this initialization table where we have the basic information about OpenClaw, we also got two other tables. We have a tasks table where the agent has instructions to create, read, and update tasks by task name. It adds details. Once the task is done, it's going to mark it complete. And we also have an is recurring field if there's something that you want n8n Claw to do over and over again. Now, a single task can be very complex. So along with the tasks table, we also have a subtask table where each subtask is connected to a parent task. So you can have one complex task, and that complex task is then divided into smaller things that n8n Claw can go ahead and complete for you on every iteration. And obviously we also have the timestamp so you know when exactly everything happened. So through this task database, you can actually keep tabs on what exactly it is that your n8n Claw instance is doing. So that's persistent memory solved. We can also update the user and the heartbeat, and the agent's system prompt contains instructions where, if the agent feels that it's received some new critical information that's worth remembering in a more permanent fashion, it can actually go ahead and update that user info and also update the heartbeat. All right, now for proactivity and multi-agent workflows. Proactivity is actually deceptively simple, and OpenClaw actually works in the same way. When I was playing around with OpenClaw, with the initial hype that was going on social media, I figured that it would just automatically start doing things. But you have to be pretty specific with OpenClaw in telling it that you need to do this for me on a recurring basis, which is pretty much the same as coming to n8n and setting up a schedule trigger to get your AI agent running. So essentially everything is the same, where you have a schedule trigger. In this case, it's every hour. It pulls that same data for the system prompt from the n8n data table. It normalizes that system prompt, except with the hourly heartbeat, there's no, the only prompt is see what's pending and start working on it. Everything else is basically the same. It also pulls in the last channel that you messaged it on. Once whatever the agent was doing is complete, it has to actually go ahead and send you a confirmation of whatever it's done. And it also has last channel so that it knows where to send whatever output that it comes up with to. So essentially we're simulating autonomy by simply feeding in a fixed prompt into the AI agent every single hour. And essentially this is what OpenClaw is doing also. There was a very interesting video that I saw where OpenClaw's autonomy is basically just a bunch of cron jobs, which is a function that is set to run at a specific interval of time. And that's basically what this schedule trigger in n8n is. Now, if you wanted multiple heartbeats, you could have a hourly heartbeat where something happens every hour and you have specific instructions. In this case, I have every hour it should check what's pending and start working on it. Let's say you had you wanted to check your inbox, or you wanted to do something else on a different interval of time. You could simply add as many schedule triggers and just modify that prompt so that on every particular interval, it just goes in with that specific prompt, executes that specific task, and comes back to you with a confirmation. And obviously, once it sends you that confirmation, everything is saved in the memory, so you could just pick up that conversation from your device and give it any further instructions. Now, for multiple agents, because n8n supports having AI agents as tools for another AI agent, and you could hypothetically nest this as deep as you wanted. So in this instance, I've set up an AI agent for research, which has access to Wikipedia. It has access to Tavily Search. You could give it any other tools that you wanted. If you wanted to use SERP API, you could pull in very specific information like news or weather or whatever that you wanted. There's an email manager tool, and again, this is its own inbox. Whenever it receives that email through the Gmail trigger, it's going to process it, and then this agent will call the email manager to take whatever action is required on that email. We also have 3 worker agents, and what I've done here is each of these 3 agents is using a different model depending on the complexity of the task required. So this agent is using Haiku 4.5. So this is meant for simple work. This agent is using Sonnet 4.5, which is used for mid-level work. And this agent is using Opus 4.6, which is used for higher order thinking work. And because all 3 of these are connected to the main agent, when I ask it to execute some task, it can actually split that task up into separate chunks and delegate easy work to this one, mid-level work to this one, and high-level work to this one. Now, each of these agents is also connected to a document manager, and the document manager is really for producing outputs. For now, all the outputs are Google Docs, so we have access to various Google Docs tools and tools within Google Drive to create folders and to move files around. You could customize this in whatever way that you wanted. Let's say you had an image generation workflow. You can add an image generation workflow. You could add a video generation workflow. So thanks to the modular structure of n8n, you can really expand your n8n claw instance with whatever specific tasks that you want it to do. And that's very similar to loading skills into OpenClaw. So you can think about skills as a very specific set of instructions for AI agents to execute. Sometimes those instructions will not require any outside input or outside output, where it's just a framework for an agent to think in a particular way. At other times, skills can have the agent actually go ahead and interact with other things. And in that case, it requires an API. Most of the skills that you'll find for OpenClaw can actually be replicated to a reasonable degree as AI agent tools with their own specific set of API calls and n8n workflows. And things get really powerful when, if you've already been working with n8n for a long time, you've probably got a pretty impressive library of workflows that you've already built. You could simply attach those workflows as tools to any of your agents. And suddenly you have this very well-connected ecosystem, so many different things that you can achieve. Another advantage of this structure is that we're using different models for all of the agents. We're only feeding in as much information as is required in every run. So overall, this is going to save you a lot of money in token costs as well. Now, I'd be remiss if I didn't talk about the limitations. This is a light version of OpenClaw and not a one-to-one clone. Obviously, OpenClaw is a very advanced piece of software. Limitations are browser control, but you can work around that limitation by using other browser automation APIs. Essentially, you're going to be using almost the same amount of credits, so you could hypothetically replicate that to a certain degree. Another limitation is shell access, where OpenClaw can hypothetically access your entire computer's file system through the terminal. You could do this to a limited degree in n8n by using the execute terminal commands feature. But again, once you start using the terminal, once you start using browser automation, that's really where your API tokens start really burning up, especially if you're using more advanced models like Opus 4.6 or Gemini 3 Pro. But this limitation can also be thought of as a function, because essentially it's a more secure version of an autonomous AI agent with very persistent memory. So here you can really control the access of this agent to whatever domains that you wish to extend it out to. If you don't give it access to certain tools, it's not going to have that by itself. I've uploaded this workflow to GitHub, and I've also added some fairly detailed documentation. So you can, and there's a link to that in the description. So do go ahead and check that out if you want to replicate this on your own. And I'd really love to see how you expand this workflow to suit your own specific requirements. And if you're interested in working with me to implement AI into your agency or business, there's a link in the description where you can find out more.